to the Martin Bailey Photography Podcast. It's December 28, 2015, and this is episode 503. The zone system has kind of fallen into the shadows as digital enables us to see our images instantly and view information like the invaluable histogram even before we release the shutter. But the zone system is still a useful tool and something worth taking the time to understand, whether you use Ansel Adams' original exposure techniques or not. I'm sure most of you have heard of the zone system, and some of you will already have a good understanding of what it means and how to use it, so this might not be new to you, but it's a great topic to explore, and I find it totally relevant as a follow-up to my recent episode about creating camera profiles for the Sekonic L758D Digital Master Light Meter. First, I'm going to explain what the zone system is all about and intersperse my own take on its applications within digital imaging. We'll also take a look at how you can use a light meter to evaluate your options in the field as you create your images and evaluate your images on the computer, both of which can be invaluable to help you understand exposure. The zone system was developed by Ansel Adams with Fred Archer way back in 1940. It's a system to map the various tonal regions or luminance of objects in any given scene to enable the photographer to reach the optimal exposure during the capture of the image and the developing and printing of a negative. Okay, so in the last paragraph, the word optimal is my take on this, but Adams' goals were the same. It's not so much about accurate exposure because there really isn't one. Adams phrases this as photographs being interpretations of the original subject values and subjective departures from reality. The zone system was most useful as initially intended to control the exposure of individual sheets of film rather than rolls of film, because the development and print process could be adjusted for each negative based on shifts applied during the initial exposure of each sheet of film. There are, of course, limitations on the developing process when using roll film, as all images on each roll are developed in exactly the same way. Ironically, in the digital age, one could argue that the zone system is more applicable again as we go back to being able to adjust our processing of each frame individually, including during the digital printing process. The zone system basically maps tones into 11 ranges of values from pure black to pure white. How people associate these tonal ranges to numerical values seems to vary, but I've split two ranges into equal parts as Adams did, and created a reference chart on which we'll base parts of this discussion, including a slightly modified description of what each zone meant within the zone system. If you're not already there, you'll need to go to the blog to view the chart and the screenshots that I've captured for this week's episode, and you can find those at mbp.ac/503. As you can see, the chart has 11 zones that are marked in Roman numerals from 0 to X for 10. The reason for the Roman numerals was to differentiate the zone values from exposure values or any other arbitrary numerical scale on the light meter, which are usually written in regular Arabic numbers. I've added two scales to the chart, one from 0 to 255 for RGB color values, and a second from 0 to 100 for lightness values. And I'll talk about how you use these ranges to evaluate your images in Photoshop later. The zones themselves, starting at 0, represent pure black. Zone 1 is near black with slight tonality but no texture. Zone 2 is textured black the darkest part of the image in which slight detail is recorded. Zone 3 is average dark materials and low values showing adequate texture. Zone 4 is average dark foliage, dark stone, or landscape shadows. Zone 5 is middle grey, clear north sky, dark skin, average weathered wood. Zone 6 is average Caucasian skin, light stone, shadows on snow in sunlit landscapes. Zone 7 is very light skin, shadows in snow with acute side lighting. Zone 8 is lightest tone with texture, textured snow. Zone 9 is slight tone with texture, glaring snow. And Zone 10 is pure white, light sources and specular highlights. Adams further defined groups of zones in the following ways. Zones 0 through 10 represent the entire range of zones from full black to pure white. Zones 1 through 9 are what Adams referred to as the dynamic range, and this represents the darkest to lightest tones that can be considered useful. Zones 2 through 8 were referred to as the textural range, which represents tones that convey a sense of texture and recognizable substance. Although I've seen heated arguments as to whether or not one zone is equal to one stop of EV or exposure value, Adams himself clearly states that this is how he intended the zones to be used in his book The Negative, in which he fully describes the zone system in glorious detail. If you still want to know more about this subject after today's post, I strongly recommend that you pick up a copy and read it yourself. In fact, it's just a great read for any photographer, so I highly recommend it either way. Now, in practice, we'll find that as the dynamic range that our cameras can record increases, strict use of the zone system requires that we will have to move away from thinking of each zone as one stop of exposure, or simply use more zones, keeping the zone to EV stop relationship. But as of 2015, most cameras have a dynamic range of about 12 stops. As we found in my recent discussion about creating profiles for the Sekonic L758 light meter, I actually have measured a range of 11.9 stops on my Canon EOS 5D SR, and DSOMark have it at 12.4 stops. So we're at around 12 stops of dynamic range in digital terms. This is the full range from full black to pure white, and I consider almost the entire range to be useful. So it's a bit wider than Adams' definition, but in practice I found that even now, thinking of each zone as a stop of exposure works fine. Just in case this talk of stops has you scratching your head, this is how we talk about the steps of exposure, controlled by three main camera settings: the aperture, shutter speed, and ISO. We can also change exposure with filters such as neutral density filters, which we talked about in episode 391. As usual, you can get to any episode by just adding the short link, so mbp.ac/391. But I'll be linking to all of this stuff in the blog post, so anything that I call out, check the blog posts at mbp.ac/501, and the chances are that when I call things like that out, they're going to be linked. Anyway, modifying your camera's exposure by one stop, you could, for example, change your aperture from f5.6 to f8 or from f11 to f16, with some of the main full stops of aperture being f1, f1.4, f2, 2.8, f4, f5.6, f8, f11, f16, f22, and f32. Because the aperture value represents the area of a circle, they are approximations of a sequence of numbers that are the power of the square root of 2. Although it can be confusing at first, this means that the smaller the number, the larger the area of the circle, and therefore the more light passes through the aperture and onto our camera's sensor, increasing the exposure. Less is more. This also has the effect of increasing or decreasing the depth of field of the scene or subject being photographed. For more information on how that works, check out episode 132 or more recently episode 437, in which we discussed hyperfocal distance. Shutter speeds are easier to grasp because you simply halve or double the time to change up or down by a stop. One stop faster than a 500th of a second is a 1000th of a second, and one stop slower is a 250th of a second. A stop slower again is 125th of a second, but then the next stop slower is a 60th of a second, so it's not quite half. In fact, the real shutter speed for 125th of a second is 128th of a second, and a stop slower should be a 64th of a second. They're mostly adjusted slightly, but there's no reason to be concerned about this. You get used to the actual numbers used. The ISO range can also seem a bit confusing, but again, as you use it, you'll get used to it. Film years ago was much slower or less sensitive to light, but these days, although some digital cameras start at the expanded ISO of 50, most start from ISO 100. To increase the ISO in full stops, you just double the value for each subsequent ISO. So one stop more sensitive than ISO 100 is 200. The next full stop is ISO 400, then 800, 1600, 3200, 6400, and so on. A full stop increase or decrease in aperture, shutter speed, or ISO will have the same effect on your exposure. For example, an exposure of f8 for a 250th of a second at ISO 200 can be made one stop brighter by changing our aperture from f8 to f5.6, one stop larger. Or we could make our shutter speed twice as long by changing it from 250th of a second to 125th of a second. Or we could make our ISO one stop more sensitive by changing it from ISO 200 to 400. Okay, so back to the zone system. Ansel Adams wanted a way to evaluate the exposure levels of a scene so that he could place certain tones at certain places and calculate from that exposure whether or not the other tones in his scene would be too dark or too bright, and adjust the exposure if necessary to protect those extremes in contrast. As I said, this also carried over into the development process, which was adjusted as necessary as well. But we won't go into detail on that here as it's not really relevant for digital. Again, if you want to understand this more, Ansel Adams' The Negative should be your first stop. No pun intended. Well, maybe a little bit intended. You would start metering your scene by identifying the tone that you would place in zone 5 or V. In black and white terms, this is called the mid-grey or middle grey, but in colour photography, let's call it the mid-tone, as it's referred to on my light meter. The beauty of this first step is that if you can't easily identify what in your scene is the mid-tone, if you're outdoors with the same light falling on your scene as where you are, you can simply take a meter reading of an 18% grey card to get this exposure value. There are lots of conversations around the web regarding whether cameras are calibrated to 18% grey or 12% grey or 12.5, 13, 14%, etc. During the creation of my camera profile using the Sekonic L758D light meter and the Sekonic Exposure Profile Target 2, I first took meter readings with both incident and reflected light from the 18% grey side of the target. I then set my Canon EOS 5DSR camera to the exact same settings that my Sekonic L758D light meter measured, and the exposure scale on the camera indicated that there was zero discrepancy from what the camera's spot meter measured. The meter reading was exactly the same, and this tells me that Canon is using 18% grey. This can vary depending on the light source, but this result is good enough for me to proceed with this article using 18% grey as the middle grey, and you'll also learn why I don't think this is totally important in the age of digital, and with the understanding that Ansel Adams adjusted exposure as necessary, we also know that it wasn't something to get too bent out of shape about, even during Ansel Adams' day. So, the starting point for setting your exposure with the zone system was to identify your mid-tone or middle grey. You can do this by viewing your scene and taking meter readings from a number of subjects that you think would be close. Adams would look for something that he felt would spoil the photograph if it was allowed to become too dark. Although he does talk about using an 18% grey card in the negative as well, as a way to get an accurate exposure if that is what you require. When you first take a meter reading from your scene, the light meter will interpret the luminance value as though the substance being measured was a middle grey. Although you can change this functionality, the meter will often assume that the first reading that you take is the mid-tone and start to record subsequent measurements in relation to this mid-tone or middle grey. I generally like to start my metering with an incident light measurement when I'm outdoors, assuming that I'm in the same lighting conditions as the scene I'm photographing. This, of course, would not work if I was in shadow photographing a brighter area not under the same cover. The thing that I absolutely love about using a light meter, though, is because they are measuring the luminance of a subject, unlike a camera's built-in metering system, they don't try to convert everything to a mid-grey. If I take an incident meter reading of the light falling on a snow scene, then take a reflective meter reading of the snow itself, the snow will be around 2 stops brighter than the incident meter reading. I'd get the same 2-stop difference by taking a reflective meter reading of an 18% grey card as the base. If this isn't making much sense, get a piece of white paper and a piece of black paper, or anything that is black, but both need to be big enough to fill the frame of your camera. Put the camera in aperture priority mode and set the aperture to say 5.6, and ensure that exposure compensation is at 0. Film the frame with the white paper and take one photograph. Then put the black object in the same place as the white one under exactly the same light, and take a second photograph without changing the settings. Then, on the back of your camera, flick between the 2 images that you just shot. You'll most likely find that they're both exactly the same. They'll be a mid-grey. To actually make them black and white, you'd need to add +2 stops of exposure compensation when shooting the white paper and -2 stops of exposure compensation when shooting the black paper. As another learning exercise, with my light meter, I like to play a game where I measure the light falling on a scene using the incident meter, which, by the way, is the method using the white dome on the light meter, and then press the memory button on the meter to record that base measurement, and then try to meter something else in the scene that is as close to this incident meter reading as possible. You can do this in your living room or outside, it doesn't matter. This helps to train your eye to find the midtones in your scene, and can actually be quite satisfying when, for example, you meter the light source and then find something that's within just a third or two-thirds of a stop brighter or darker than the incident light measurement. A little geeky maybe, but this is the sort of thing that I've done over the years to hone my skill with estimating exposure, and that's a big part of what this is all about. Okay, so let's get back to metering your scene in the field now. It's not important that your metered midtone is absolutely the middle grey, as we'll adjust this anyway, based on the following part of the exercise. You now need to identify and measure the lightest and darkest parts of your scene. If you are following along with me here, with your own light meter, figure out how to memorize the tones that you are measuring. The Sekonic L758D can memorize up to 7 meter readings by pressing the memory button on the left side underneath the spot metering lens. Once I have my incident light measurement saved, and probably 1 or 2 reflective measurements from what I thought were the midtones in the scene, I'll start to measure and save the luminance values for the lightest and darkest parts of the scene. If the sun is in your scene, there isn't much point in taking a meter reading from the sun's disk itself, and you also need to be careful not to look directly at the sun through the light meter's spot meter viewfinder, as many of these are magnified so you could damage your eyes. In the zone system, the sun would also be considered a specular highlight, falling into zone X or 10, so we wouldn't try to prevent it from overexposing anyway. Do take a reading though, for example, of bright cloud near to the sun, especially if it's important that there's some detail recorded in these areas. The same goes for the darkest parts of the scene. Record some values from foreground rocks, for example, that might have their shadow side facing you. These might be very dark. If you find that the shadow areas in your scene are very dark, you have to make a decision as to whether or not the detail and texture in the rock is important. In the original zone system, if your shadow areas were more than 3 stops darker than your midtone, you would start to lose the appearance of substance or texture in these areas. This means, for example, if your midtone zone V or 5 with the aperture set to f8 was metered to give you a shutter speed of say 125th of a second, and your dark foreground rocks were metering at an 1/8 of a second, that's 4 stops darker, putting the rocks in zone 1, and that's where the zone system is defined to have slight tonality but no texture. If you were to go to 1/4 of a second, that would put your rocks in zone 0, so they'd be completely black with no visible texture. As we'll see later, this is one area where modern digital imaging has exceeded the boundaries of the zone system as defined by Ansel Adams, because it was based on old film which had a much smaller dynamic range. This means that now we would need to either remap the zones to not mean 1 stop of EV per zone, or do what I do, which is just learn how far we can push the exposure and work to new boundaries, but still keeping the zone system in mind. So if you do need to protect your shadow areas for some reason, say that they are even darker and you feel that there will be no detail there, even with the dynamic range of your camera, which we'll talk about shortly, then you'll have to consider brightening up your image. The major difference with the film-based zone system and how it's applied to digital imaging is that in the film days, it was much easier to recover detail in bright or overexposed highlights than it was to recover lost shadow detail. In The Negative, Adams says, and I'm quoting him directly here, "The low values, shadow areas, are controlled primarily by exposure, while the high values, light areas, are controlled by both exposure and development." In digital imaging, once we've overexposed our highlights, there's no way to get any detail back. So we have to do the reverse and protect our highlights when shooting digital. If we look again at the graph showing data from my 5DSR during the creation of my camera profile, we can see that the drop-off of information in my shadows is a much shallower curve than my highlights. So there's a much better chance of me saving my shadows than salvaging detail from blown highlights. If, like me, you use a technique called ETTR or exposed to the right, this means that you set your exposure so that your highlights are almost or even just touching the right side of the histogram, and then let the midtones and shadows fall where they will. Adams uses the term place and fall when describing the zone system, meaning that you find your midtone or zone V5 exposure tones and then let the shadow and highlight detail fall where they will, unless you have to adjust exposure to protect either of the extremes. You can do exactly this in digital as well, and with today's image quality, your images won't suffer much for this. But because of the way digital images are recorded, we get more and more grain as the midtones and shadow areas get darker and darker. So you'll get better quality images by recording your image as brightly as possible. And this is exactly what ETTR does. Even if my darkest shadows are only in zone 5, I still expose for the highlights, and if necessary, I can darken the image down in post, getting the same exposure that I would have if I'd exposed those midtones in the middle of the histogram. But I have much cleaner shadow areas using this technique. I place my highlights as close to the right as possible and let the rest of the image fall where it will. I use this technique pretty much across all of my photography, and I love the results I'm getting. Note too that even when my shadow areas seem incredibly dark, I'm still getting detail from these areas utilizing my full 12 stops of dynamic range, as we'll see in a moment. We can consider this digital place and fall. If you recall from episode 501, in which we created the camera profile for my 5DSR and transferred it to the Sekonic L758D light meter, the reason I was so excited about this is because it enables me to show the dynamic range of my camera right there on the meter. So I can see if the luminance values in my scene fall inside the capabilities of my camera to record without over or underexposing my highlights or shadow areas. In practice, because I've been using the meter for around 15 years, mostly as a learning and teaching tool, I don't meter my scenes in the field all that often, especially as we can see the information that we're capturing right there in the histogram. But I'm really excited about having my dynamic range displayed right there on the light meter's exposure scale, both to work with students, but also just to easily check the extremes of contrast in my scenes as I evaluate my options. Let's now jump into Photoshop and evaluate a photograph that I made on my Hokkaido Landscape Photography Adventure Tour in January 2015. We'll open the original photograph straight out of the camera, and then I'll show you the final image after converting it to black and white and bringing out all of the lovely detail in the tetrapods in the foreground that I knew would be recorded, but really could not see in the image as I reviewed it through the viewfinder or on the LCD display on my camera. If you don't have your info panel displayed in Photoshop, hit the F8 key or click on Info under the Window menu. Then click the button in the top right of the info panel and select Panel Options, and you'll see the dialog that I'm showing you a screenshot of right now. I have my first color readout set to RGB color, and my second color readout set to lab color. Then, from the Photoshop toolbar, select the Color Sampler tool, which you'll see when you click the eyedropper tool. Now, as you roll your mouse over the image, you'll see the numbers in the info panel change, showing you the values of the tones that you're rolling over. These numbers correspond to the ranges of numbers that I added to the zone system chart that we looked at earlier. So if you click on that image, then drag it to your desktop, click on it to view it large, and then grab the middle of the image and drag it to your desktop, you can open that as a reference. The other cool thing about the Color Sampler tool is that when you click it, it adds a little marker to the image, and you can see all of the lightness values of the tones that you click on. The L in lab, as in the lab color that we selected earlier, stands for lightness and ranges from 0 to 100. Once you're at 0, you are recording pure black, and at 100, you're recording pure white. These are the absolute extremes of the zone system. After you've clicked to record a sample, if you right-click it, you can change it to lab if you prefer to reference the 0 to 100 scale, which I personally prefer for this exercise. Before you start to sample tones, also change the sample size to 31 by 31 average in the top toolbar so that you aren't sampling too small an area. Here's a screenshot of my 3 stat samples, and you'll need to click on the image to see the sample marks and maybe even drag it to your desktop and open it on your computer to see. But in the middle of the image, you'll find my first sample, which we can see in the top right has a lightness of exactly 50. That's smack in the middle of zone 5. This is my mid-tone for the scene. If you look at the second, easier to see sample 2, you'll see that the lightness value is 99, so it's a hair under 100, where all detail is lost. That's the brightest part of the scene and very close to being totally blown out. Down in the bottom left corner, you'll see sample 3, which has a lightness value of 1. This is the darkest shadows I can record and still have a chance of recovering any information. Looking at this image on your computer, if you have your display calibrated and the correct brightness, you really shouldn't be able to see much down in that bottom left corner. That's how it looked through the viewfinder and on my LCD screen in the field as well. I went ahead and made this exposure though because I knew that these values were close but not totally out of my dynamic range. If you know my work, you'll probably know that I'm a huge fan of black and white photographs, and even as I shot this image, I knew that I would take it into Silver Efex Pro 2 and convert it to black and white as my final image. I've done tutorials on Silver Efex Pro in the past, so we won't look at that today, but I wanted to point out one important feature of Silver Efex Pro that I use before saving every image that I convert to black and white with it. Again, you'll need to click on the image and open up your browser window as wide as possible to see this full size. But if you look down in the bottom right corner, you'll see 11 small boxes ranging from black to white, numbered 0 to 10. You've guessed it, this is a dynamic indication of the zone system right there in Silver Efex Pro. Remember that once you've clicked on an image on the blog, if it continues to advance automatically, just place your mouse over it and it'll stop. It'll just hang on that image until you either click or move your mouse away. As you can see in this screenshot, when I rolled over zone 10, there are some diagonal lines that have appeared over the brightest part of the sky where the sun's rays are radiating from. If I wanted to, I could have brought these down a little in my final image, but I actually consider these silver linings on the clouds as specular highlights and decided to leave them this bright. As long as I know which areas are bright, I can make the decision as to whether or not I will change the image. And that is the beauty of these zone system displays. I am, though, less likely to allow shadows to totally plug up because blacks tend to print really dark anyway. For this image, when I rolled my mouse over zone 0, there were no areas that are totally black. This screenshot that I've got here now shows areas that are in zone 1, and they're basically limited to areas of deep shadow, which is exactly how I planned this photo. Finally, once I saved the image and returned to Photoshop, you can now see the new values from the black and white image as the color sample markers are still in place. My darkest shadows have increased from 1 to 5. My brightest highlights have come down from 99 to 98, and my midtone has become very slightly brighter at 53. The important thing to note here as well is that what appeared to be very deep shadows in my original image actually contain a lot more texture and detail than you might have thought, especially if you'd seen this on the back of the camera as I shot this image. It's at times like this that many people start to think of HDR to increase the dynamic range. But as I've mentioned in the past, I rarely do HDR as I don't believe it's necessary. If HDR is a creative avenue for you, then that's fine. But if you don't particularly enjoy the process, then hopefully some of what we've covered here will help you to rely a little bit more on your camera's ability to capture a full range of tones. Just to clarify as well, before we finish, the image that I've used in this example was shot with my 5D Mark III, not the 5D SR. The 5D Mark III actually had a very slightly less dynamic range than the 5D SR, so we'd be looking at very similar image examples anyway. Okay, so to wrap this up, I'd like to reiterate that you don't necessarily need a light meter to make great photographs. I didn't meter this scene in the field. I relied totally on the histogram, which I do believe is an essential tool, especially when we're pushing the extremes of our camera's dynamic range. I also find it very important to turn on highlight warnings on my camera. The highlight warnings are based on the in-camera JPEG, so I tend to keep my picture style set to neutral or faithful so as not to change the image very much. But it's still an 8-bit JPEG, and there's much more detail and information captured in the RAW file. I use the preview as a guide and sometimes set the exposure so that I'm just starting to blow out my highlights. And then I find that the resulting images are actually just inside the limits and very usable, right up to a point that would probably have had Ansel Adams rethinking his zone system as well. If he was still with us though, he would have embraced digital with open arms, and I'm sure he'd be pushing exposure to extremes like this, pulling as much out of the technology as possible. If you're thinking of buying a light meter, although it's been on the market for a while now, I can't recommend the Sekonic L758DR Digital Master Light Meter enough. The ability to create those camera profiles using the Sekonic Exposure Profile Target 2 takes its usefulness to a whole new level. As you can see right there on the meter exactly how your scene maps to your own camera's dynamic range. If you haven't already, check out episode 501 for more detail on that. The other important feature of the Sekonic L758D or DR in the US is that it has a 1-degree spot meter, which is vitally important for taking accurate readings from your scene. Many other meters have a 5-degree spot meter, which are way too wide to really pick out and meter fine details in your scene. Although the light meter is not 100% necessary today, as I've mentioned, I do find them very valuable as a way to learn about exposure and light and how it affects your images both in the field and in post-processing. I also find the light meter to be very useful as a teaching tool. So if you teach photography yourself, it's also definitely worth considering. And I've included a number of exercises today that you can do yourself, so I hope that this whole post has been useful for you. Before we finish, this is the last episode of 2015, so I'd like to wish you all a very, very happy new year and all the best with your photography and your life in general. I'll be back with an episode where next week I'm going to bring you my top 10 images for 2015. And this is an exercise that I've been doing each year now for a number of years. I find it really useful. So I'll share some of the details of the process as usual and share my top 10 images from 2015. And then I'll be off on my winter tours. So I'll be sort of here and there over the next few months. But I will be broadcasting through 2016 and on. So I hope to see you then. Thanks very much for listening today. If you enjoyed this podcast, please share a link with your friends. And if you don't already, please subscribe in iTunes or your favorite podcast program to ensure uninterrupted delivery. You can find me on Google+, Twitter, Instagram and Facebook, etc. And links to everything that I'm up to are at martinbaileyphotography.com, so do drop by and take a look. I'll be back next week with another episode. In the meantime, you take care and have a great week, whatever you're doing. Bye-bye.